Hey guys and girls, welcome back to BBR Suspension. Okay, so today we are going to get started with calibrating the 1-inch die for the tube bender. So if I can just explain how it works. When the tubing is drawn through the die, it actually pulls the tubing through. So on the inside of the radius, it needs to shrink the tubing, and on the outside of the radius, it needs to stretch slightly. So what we need to do to be able to get fairly accurate bends, we need to calibrate the die, and what that basically does is we will make a mark on the tubing. So that mark we line up with the edge of the die. We then do a 90-degree bend, and we'll measure from the bottom end to the top, if that makes sense. We'll take a measurement from the underneath of the tubing to the top of that leg, and vice versa, and then we can input it into the BendTech software, and what that does is that will work out how much shrinkage and stretch we have on the tubing. So for each die you're going to have a specific centerline radius, but the actual achieved centerline radius is not going to be quite the same. It's going to differ by a couple of millimeters or a fraction of an inch. So what we've done is I've taken a piece of the 1-inch cold roll tubing that we're going to use. It's got a 2mm wall thickness. It's the thickest I can get at the moment, but it'll be ample for what we're doing. Very, very strong stuff. What I've then done, I've taken a piece of nylon and just turned a little sleeve which will slide onto the tubing, and this is nice for marking the tubing because it allows you to do a mark right round that's always exactly perpendicular to the center line of the tube. So I've got that all sorted out. What we're then going to do, we're going to put a mark on the tube and draw a line round, and that mark will line up with the edge of the die. I'll show you that in a second, but we'll line that up with the edge of the die. Once we've got that lined up, we'll do a 90-degree bend, and we're going to measure. We want to be within 1.5 degrees of 90 degrees exactly, because then once we input that into the software, it'll calculate the actual achieved centerline radius, and it'll also work out where we need to clamp on the start of a bend, so that depending on how you draw it, if you draw it from apex to edge, there's a couple of different options in BendTech, but it'll give you the actual start points of where you need to start the bend and where the bend should finish. So what we're going to do, we're going to get started with the calibration. So what I'll do is I'll just run through it again quickly to explain how we do it, and then we'll head over to the bender, get everything installed on the bender, get the sample set up, and then we'll do the 90-degree bend, take our measurements, input it into the software, and then I can start redrawing the actual components, and we'll get cracking with the bending. Okay guys, so how this works, we're going to put a mark on the tubing, which we're going to line up with this edge of the actual die, and we need to make sure that that specific mark, this hoop, slides over the tubing, and we've got a pin that'll drop through, and this bolt is used to lock the tubing up against that collar. Again, that's what holds the tubing. So what we need to do is we need to make sure that the tubing lines up roughly with the edge of this collar or the clamp, and then we need to see roughly where it's going to line up with the edge of the die. So that measurement is quite important because we need to input that measurement into the software. So I'm measuring approximately 80 millimeters, which is about just over 3.5 inches. So what we'll do, we're going to make a mark on the tubing 80 millimeters from the edge, and that 80 mil I will input into the BendTech software. So what we'll do is we'll make a little mark there. I then take the sleeve that I made, and we draw a line right around the tubing with a Sharpie marker. And that is going to be our reference point. So when we get to doing the bend, we're going to clamp the tubing like that. So that line is going to line up with the edge of the die. Then what will happen is the die is going to basically turn in a clockwise direction, and our follower block here is going to basically follow the tubing. So as the die turns, the tubing is going to get drawn through the follower block, and that's what I was explaining earlier. You'll get a little bit of compression on the inner wall or the inside of the bend radius, and we're going to get some stretch on the outside, and that's what we need to measure, so that once we've inputted that, the BendTech software will then compensate for any future bend. So when you draw something up, you're not out on your measurements, it factors those in. So this is quite an important step, and all my other dies that I do have, I've calibrated in the exact same way. If you guys have used the BendTech software before, it's got a fairly decent wizard which explains the entire process exactly as I'm explaining it, just that it's obviously a written note. So what we'll do, we're going to head over to the actual tube bender, we're going to get everything set up, and I'll do the actual calibration with you guys on camera so you can see exactly how it's done. We'll then take the measurements, input it into the software, and get cracking with redrawing these components. Okay guys, so this is our sample tube that we've done, or that we've cut, 460 millimeters long, and we've marked 80 millimeters from the front edge, and that is the section that we're going to basically be clamping in here. Okay, and then what we're going to do, we're going to then do a 90-degree bend on it. So we're going to get it prepped. So what we're going to do, we're going to put a little bit of this bending lube. It's quite a thick gooey oil, but what it does is it just allows the back of the tube to run against the stationary block. So we just give it a little wipe with a bit of this lube just to help it through. We'll then insert the tube, and what we'll do, we'll get it lining up with the leading edge of the die. Okay, I always like to do the seam of the tube on the inside of the die. Might be a personal preference, but what we'll do is we'll just tighten this locking bolt up to hold the tube. So just a free state micrometer or Mexican speed wrench, wherever you're from. Okay, so we got the line that we've marked lined up with the edge of the bender. We then take the backing block, and we need to get it onto the edge of the tubing. Let's just see why I'm not getting it through. There we go. Right, so I'm just going to put a little bit more of the bending lube across the back of this tube, so we know that it will drag through the die, okay. Right. Then what we'll do, we get our handle tightened up, and we've got an indicator block that clamps on. What we'll do is we'll just get it lined up with the 0-degree line. So we're going to bend to 90, and what we'll do is sometimes you've got to go past the 90-degree mark because of the spring back on the tubing. Once we've got it to 90, we can check. So ideally it is quite a difficult thing to be able to measure this without taking the tube out, but for the intent and purposes we should be able to get, once we've taken the pressure off, back to 90, and if we're at that point we should be pretty close to the 90-degree mark. So what we'll do is we'll start by getting that bend done. So we'll crank it and ratchet that. Next position. So we're at about 88 degrees now, which means we got to probably push to about 92 degrees, maybe 93. Okay, perfect. We're basically on the 90-degree mark. Just doing a visual on here, and it looks like we're still out a little bit, so I'm going to take it out a further 2 degrees. That looks better. We should be at about 90 degrees there. So what we'll do now, we can kick this back, just move our guide block back slightly. And what we can do is we can take the indicator off, loosen the pinch bolt, and take our sample out. So as you can see, pretty nice bend, no crazy marks. Those marks, you can see what I was talking about earlier on, the stretch marks on the back of the tubing. So as this piece bends, this side stretches and the inside of the tube actually compresses. Okay, so that's the reason why we've got to do this calibration test. What we'll do is we'll measure it up, and I'll pop the numbers into BendTech, and then we can get cracking with drawing up the actual components that we need, and do the coping templates as well. Right guys, so we've taken all the measurements, we've basically plugged it into BendTech, and I'm going to try and zoom in so you can see. So on that 3.5 inch centerline radius die, we should be achieving a centerline radius of about 92 millimeters, and the actual effective radius that we get is about 99.568 according to BendTech. So those are the measurements that we can work with. So now that we've got the die calibrated, I can redraw the actual components, and we can work out our coping patterns, and then we can take it from there. So we'll get cracking and redraw the components off camera, and then we can get the material cut and ready to actually bend up the sections for the next stage of the build. Right guys, so we've prepped up 2 pieces of tubing which we're going to be bending, and these are going to be the top A-arms of the Porsche suspension. What I've done, I've marked a couple of lines. The first line that I've marked is according to bend tech, which is where the bend is technically going to start. It doesn't actually start there though. It starts a little bit further on, but that is the line that we need to line up with the edge of the die, and that's the same as what I showed you when we calibrated the die with the piece doing the 90-degree bend, where we start on the edge of the die. The second line that I've marked and the very last line are, according to the drawing, 126 millimeters in, and the third line that I've marked is basically the center of the length of tubing. So I've prepped the two lengths like this, and what we're going to do, we're going to be putting a 77-degree bend. So the 77 degree is the included angle. In other words, from the center line it'll be 38.5. That's according to the drawing. So we're going to be doing an included angle of 77 degrees. And then what we'll do, once I've got that bend made, the reason why I've marked that line is where the camber adjuster goes through the center section. I'm hoping to be able to clamp this in the mill and cope that with a hole saw instead of doing a sort of hand cut, let's call it. What I've done is I've 3D printed a coping template for both ends, and that I'll trace on as soon as I've got the bend, but it's easier to do the bend first. Just gives us a little bit more material on the end to clamp to. And then, as I explained previously, you're going to shrink the middle section and you're going to stretch the outside section slightly when you bend it. So I'd like to see where that center line finds itself. So that's the reason why I've put the 3 additional marks on. So what we'll do is we'll get cracking with the bending. We'll bend these 2 up, and then I can work out the exact distance to where the cope needs to go, and we'll mark the cope on them, and then we can actually cope the ends of the tubes. Right, let's get cracking. So what we've done, I've got the first piece of tubing set up in the bender, just making sure that I did nip. I've got the line, which, like I'd shown you on that one, I've marked the very first line with an X, and that is the one that we've got to line up with the edge of the die. So I've got that set up. I've got my indicator on 0 degrees. We've got a little bit of tension, so what we'll do is let's get cracking with the bend. And once we've got it to 77 degrees, we'll check for spring back, we'll loosen everything, check if it kicks back. If need be, we might have to push it by an extra degree or so. Let's get bending. We're on about 65 degrees now. We're on about 76. So we'll give it a smidge more. That's perfect. We're on 77 degrees now. And you can see the lines that I'd marked. That's the first line, which lines up with the edge of the die. The second line is technically where the bend actually starts. That is our center line, and then the third line is the equidistant from that edge to the outside edge, and that should be where the bend stops. So if you look on a vertical perspective, you can actually see that the bend starts roughly between those 2 lines. You can see the tube starting to narrow slightly. Right, so we'll get the second one set up quickly and get that bent. So what we're going to do, we're going to loosen everything first. We'll just drop this back in and knock this backwards. We'll get our backing block just moved out of the way for now. And we can loosen a clamping bolt. So you can see the center of the bend is probably about 10 millimeters to the left of the line, and that indicates how the tubing gets drawn through the bender, like I explained when we were calibrating it. So that was just a reference to be able to show you how it moves, and that line there is the equivalent, the edge to that line is the same as that side, and you can see how the tubing flattens out more. But that is a perfect bend. No crazy marks on it. So what we'll do is we'll pop that aside, we'll clean that up now, and then we'll get started with the next one quickly. We'll get some bending lube onto the next one. Right, so there's the second bend done. I'll hold the two together. You can see we got pretty much identical bends. You can see that the bends start pretty much on the same spot. So we've got the two bends done, and what we'll be able to do, we'll get them set up next, take a few measurements, and we can transfer the coping pattern, and then I'll get them cleaned up too. Right guys, so we've got the bends done, and what I've done, I've just checked them with the digital, let's call it protractor. So what I've done, I've taken the bends and measured on the outside. Okay, just trying to give you a bit of a show there, and I'm measuring 78.1 degrees. Not too sure. See if you can see that 78.1 degrees, which is pretty damn close. Because we're going to be notching in the center, 78 degrees is fine. We don't have to bend anymore to get the extra degree. It's not going to make a world of difference. So basically I'm happy with those two bends. We've got the two bends done. They're matching up identical. So what I'll be doing now, I'll just be starting to make some marks on the table. I can line them up, and then I can figure out the exact position of the coping template. We can get the coping template marked and then get cracking with the coping of the tubing. I'll see you in a few minutes and we'll get cracking with the coping. Right guys, so what we're going to do here is get the center of this A-arm so that we can basically get a pilot hole drilled. We're going to use our edge finder, bring that down. So that we can get the center of the tube, and then what we'll do is once we got the center of the tube, we'll basically get a hole, we'll center the tube left to right, and then let's call it on our y-axis first, and then on our x-axis get the center. We'll drill a pilot hole, and then we're going to basically push a hole saw through. And once we get through with the hole saw, we're probably not going to be able to get all the way through just because of the fear of hitting the vise, but I'll go as long as or as deep as we can. And then what I'll do is once I get to a certain point, the rest we can probably take it out and just drill it with a hand drill, so that shouldn't be a problem. Right, so what we'll do now, we're going to switch over to a 32mm hole saw, and we're going to pierce a hole as deep as we can there. We should be able to flip that over, pick up that hole from the other side, or I'll just punch it through with a hand drill. Right guys, so I've managed to get all the tubing coped. The center section I did on the mill, the ends I did by hand, and on the center section where I couldn't go all the way through because of the mill vise, what I've done is I've clamped it to the table and I've just gone through the last 2 or 3 millimeters with a hand drill, or the hole saw. I've then gone and deburred it and cleared it up, or cleaned it up with the power file just quickly, and cleaned all the rough edges and the burrs off. And what I've done is I've laid it out just as a mock-up so that you guys can see what the top A-arms are going to look like. So I'm at the point now where the next step is to start working out some fittings, or let's call it a jig to clamp these things in or secure them before tacking them together, and then we can start with the welding process. But I think the next stage I'm going to start working on the bottom A-arms and get them to a similar point, and then do all the welding together. It just makes a little bit more sense to do all the welding together. So what I'll do is we'll zoom in and give you a shot of what they're going to look like. I've just mocked them up to give an idea of what they'll look like. So you can see the camber adjuster in the center, the two arm sections to the side, and the pivot bushes. I've just kind of balanced them on a bit of paper towel just so that they don't roll around, but at least you can get an idea of what they'll be looking like. The next thing we're going to do is we're going to make a bush which fits into these pivot adjusters, or the pivot bushes, and that'll go onto a solid rod so that when we weld it they are exactly concentric. And what we'll do is we'll clamp those, I'll probably clamp the rod into some V-blocks, and similarly clamp this into a V-block so that they're perpendicular to one another. And then that's going to be the next stage of the A-arms at the top. But what I'm going to do is concentrate on the bottom ones and get them to a similar situation, or similar level as these ones, and we can then move forward with the welding and get them finished up.